Hello and welcome to another GUNT product video. My name is Tim Kroeger and I'm a member of the GUNT sales team. We live in a world with ever-increasing cost of energy, and right now here in Europe we are experiencing an unprecedented price hike. This is one of the reasons why at long last the humble heat pump is experiencing an explosion in popularity. Today we are showcasing the GUNT ET 102 heat pump trainer, which has been part of the GUNT product program for a long time, but over the years, again and again, we upgraded the system to represent latest state-of-the-art technology. A heat pump is a device that can heat up a building, or as in our case, water, by transferring thermal energy from the outside using the refrigeration cycle. And due to the fact that the specific heat of condensing is so much higher than the specific power input for compression, efficiency are much higher compared to simply burning fossil fuel for generating heat. As a matter of fact, the ratio between the heat discharge and the power input is called coefficient of performance or seasonal coefficient of performance. And for commercial heat pumps, the COP or the SCOP can reach values of up to 4.5. In other words, for every kilowatt hour of electric power input, we get 4.5 kilowatts of heating output, all through the magic of the refrigeration process. So in that sense, a heat pump is a reverse refrigeration system and consists of pretty much the same parts. Here in the ET 102 we use standard industry components, which means we have a high recognition of value, and the experiments are close to what the students will eventually experience in the real world. The workhorse of the system is this 5 cubic centimeter displacement hermetic compressor, the type of which you find in many small to medium scale domestic and light commercial appliances. From there we go into the coaxial condenser, which is water cooled. This is the hot water circuit where we recirculate the water through this tank, which in turn is held at a constant temperature by connecting it to a cold water supply. The water is recirculated by this pump here and regulated with this hand valve over here. The system is protected with low pressure and high pressure switches. From the condenser, the liquid refrigerant, which by the way is R513A, a fluorinated refrigerant with a rather low global warming impact. From the liquid receiver, we go through the filter dryer side glass to the expansion device. In our case, this is a thermostatic expansion valve with adjustable superheat setting. The evaporator is a fan coil unit, and the fan speed can be controlled over here. Then we have a variety of digital displays displaying values such as the temperatures in the hot water circuit, condensing temperature, evaporating temperature, and the hot water circuit flow rate, amongst others. The GUNT ET 102 can be used in a variety of teaching methods. On one hand, we have the traditional method where students gather experiment data from the various instrumentation displays, transfer them manually into a pressure enthalpy diagram, and then calculate things like coefficient of performance, specific heat of condensing, and so on. On the other hand, the ET 102 has full PC connectivity, so on a PC the experiment data can be acquired and displayed in real time. So whichever teaching method you use, you can rely on the GUNT ET 102 heat pump trainer for many years to come. We hope you enjoyed this short video. For more information, make sure to visit our website or contact us with your question. Until then, goodbye from Hamburg. And for a more detailed experiment description, click here.